Good day, everyone. And I want us to quickly solve this problem on motion. Now, if you look at this problem, you discover that this is a problem on equation of motion. We are going to use one of the equations of motion to solve. Now, looking at this problem, let us read the question first. You have a body accelerates uniformly from rest at the rate of 3 meters per second squared for 8 seconds. We are to calculate the distance covered by the body during acceleration. We have to calculate the distance covered uh, by the body during acceleration. Well, this is a wild question. Now, what are we going to do here? Now, the first thing I want you to remember is that we have equations of motion. And what is very sad is that some students will complain that they don't know how to solve this problem. I don't understand this. But if you ask the same students what are the equations of motion, they cannot produce them. Of course, you have to commit the equations of motion to your memory. Now, let me quickly write the equations of motion for you, although I'm going to clean them. I just want to write them so you can actually write them down. Now, the equations of motion are 1. V equals to U plus AT. Now, this is equation of uniformly accelerated motion. So V equals to U plus AT, S equals to UT plus half AT squared. We also have V squared equals to U squared plus 2AS. Now, these are the equations of motion that we are going to be using. And then we can also have this last one, S equals to U plus V over 2, which is average velocity times time. So now we can actually make use of all these equations to solve any problem that we have. Now let these equations, let them remain here while I explain and we check which of the equations are we going to use to solve this problem. Now, the first thing you have to do is that you must know how to get your parameters from the question. Now, let me quickly take you through these parameters. Now, can you see this V? Now, this V represents what we call the final velocity. The V represents what we call the what? The final velocity. Now, this U represents what we call the initial velocity. Now, this and this T represent the time. Now, most of these variables are present in other equations, but the one that is not present is this S, which is the distance. This S represents what? Distance, not speed. Please take note of that. Some students mistaking this S for speed in this equation. This S represents distance. Do you understand that? Now, let us check which of the equation is going to be suitable to solve this problem. Now, the first thing you have to do, please take note, is to bring out all the parameters you can get from the question while you read the question. Please try to bring out all the parameters. Now, let us look at how we are going to bring out the parameters from the question. Now, let's read the question. A body accelerates uniformly from rest. Now, one of the things students don't know, look at this rest, is that there are some parameters that they are not going to give you directly from the question. But once you read the question, you should be able to know. Now, the fact that the body is accelerating from rest, whenever you see this rest, meaning that the body was initially at rest, it has no initial velocity. So you quickly write that U equals to 0. Nobody is going to tell you anything other than the body is accelerating from rest, and meaning that you have been given one of the parameters. So if you don't know, meaning you don't know, and I don't think there's a way you'll be able to solve the problem. because your parameters will not be complete and you will be complaining. So meaning that anytime you see a body accelerate uniformly from rest, then please quickly write that u equals to 0. And what is the meaning of u? Initial velocity. Please take note of that. It is very important. Now the next is that, let us continue reading the question. At the rate of what? At the rate of 3 meters per second squared. At the rate of 3 meters per second squared. Now, some people don't read carefully. This 3 meters per second squared, in fact, the unit, which is meter per second squared, should tell you that this is acceleration, because it is acceleration that has the unit of meter per second squared. So meaning that you're going to do what? You're going to bring out your A, meaning that your acceleration is going to be what? Your acceleration is going to be 3 meters per second what? Squared, like this. Do you understand that? So once you have done that, then you continue for 8 seconds. For what? For 8 seconds. Meaning that that is your time. For 8 seconds. That is your time. So I say my time is actually what? Is actually 8 seconds, like this. Now, after you might have done that, you are not done with the question actually. So the question says, calculate the distance covered. Please, what symbol do we use to represent the distance covered? We use S to represent the distance covered. So you are going to say S. This time you don't know. The question says calculate the distance. And don't forget I said S represents the distance in the equation of motion. So please take note of that. So S, we don't know. That's why I put question mark. Now, some students don't know how to pick the equation of motion to use. Now, look at all these now, all these parameters that I've brought out from the question. Remember, the rest, look at the rest. They didn't tell us anything. They just told us that uniformly from rest. And I wrote u equals to 0. So you have to know that. You have to know that whenever they say, you see a question says, the body is starting from rest, please quickly write u equals to 0. That means your initial velocity is equals to 0. Take note of that. Now, there are other things like when a body is coming to rest. When a body comes to rest, that means a body stop. Then the final velocity will be 0 then. Or when they say a body is moving with constant velocity, they say the velocity of the body is constant. That means, the body is not going to have acceleration. Acceleration is going to be 0. Now, we are going to see how these things are being applied. But the one that we are going to apply in this question is that the body is starting from rest, and you should write u equals to 0, because they are not going to tell you to write u equals to 0. And if you do not write it, your parameters won't be complete, and there's no way you'll be able to get the answer. So thank you very much. Now, let's continue. The question asks us to calculate this. Now, we have written out all the parameters from the question. Now, check the equation of motion that are written at this right-hand side. Check all the equations of motion. Which of these contain all our parameters? Which of the equation of motion contains all our parameters? That it has the u, as a, as t, and as s. Now, if I check the first one does not have this s. So it means I'm not going to consider this first equation. Now, if I look at the second equation, you discover that it has u. You can see it has what? It also has a. You can see a here. It has t. It has t, and it has s. It has s. So meaning this equation is suitable. Second equation is suitable for us to use, and I am going to use it because the equation is suitable. So if you look at the third equation, you see that we don't even have time there. So this second equation is suitable, and that is how you pick the equation you are going to use to solve your problem. After you might have written out all your parameters. And some people will not be able to get all the full parameters because they don't understand some things like this rest now. They will not know that u is equals to 0. So that is that for that. Now, after you might have done that, then you pick the equation we are going to use. So I'm going to write now that s is equals to ut plus half a t squared. So the next thing for me to do now is to substitute the parameters into the equation. So anywhere I see s, I'm not going to put anything. I'm still going to repeat my s because it is what I'm looking for. But anywhere I see u, I'll put 0. Anywhere I see T, I'll put 8. Anywhere I see A, I will put 3, and that is it. So now let's quickly substitute our parameters here. So I'm going to say that S is equals to, the U is actually 0, so it's going to be 0 times UT is U times T. So 0 times what? 0 times time. What is our time? Our time is actually 8. So I'm not going to put the unit now, so don't worry about the unit, just substitute your numbers, then plus half. Don't forget you have this half. This half is there, so you put your half in it, times, what about the acceleration? Well, the acceleration is actually 3 times time. What is the time? 8. But don't forget that this time has squared, so you must not forget to put the square on the 8. So I'm going to have next S equals to 0 times 8 is actually going to give me 0 plus half times 3 times 8 squared is going to give me 64. Please, 8 squared is not 8 times 2, it is 8 times 8. So that's going to give me what? 64. Well, from here, I'm going to say 2 here 1, 2 in 64 is what? Is 32. And that is going to give me S is equals to 0 plus, well, let me just repeat the 0. So 0 plus 3 times what? Okay, let me write that. Let me write the 3 clearly. So that's going to be 3 times what? 3 times what? 32. So S is going to be equals to 3 times 2 is actually 6, and 3 times 3 is 9. So that's going to be 96. And what are we looking for? We're actually looking for distance. So what is the SI unit of distance? Well, the SI unit of distance is actually meter. So you're going to put your meter here like this. And that is the solution to this problem. Please, thank you very much for watching.